Hello everyone, welcome to this lecture series on COMSOL Multiphysics where we dive deep into modeling and simulation with a focus on chemical engineering application. So whether you are a student or a researcher or industry professional, this lecture series is designed to help you to understand how to use COMSOL effectively to model real-world multiphysics problems from reactor design to mass transfer, fluid flow and more. So in today's lecture, I'll be introducing the fundamental of multiphysics modeling in COMSOL and how COMSOL integrates different physical phenomena, which are especially useful in solving complex chemical engineering problems. So let's get started on this journey to turning engineering concepts into conceptual models. So here you can see that I'll be discussing the COMSOL multiphysics in different lectures. So first, I just want to make this video for keeping the chemical engineers in my mind so that they will be getting benefited. So here you can see the topic that I'm going to cover in this lecture series will be the introduction to COMSOL multiphysics, interface model and workflow. And after that, I'll be starting with setting up your first model in 2D versus 3D stationary and time dependent. And in first lecture also, I'll be covering some very fundamental concept regarding how to create geometry and how to select all of these kind of models and all of these physics, something like that. So if it's subsequent lecture, you'll be able to understand this thing. In the third lecture, I'll be talking about modeling laminar flow in reactor, that is CFD basis for the chemical engineering. Here we'll be modeling batch reactor, flux flow reactor, as well as the continuous accelerator reactor also, and so on and so forth. And after that, I'll be talking about mass transfer in porous media, that is based on the diffusion and convection model. So there will be also talking about some kind of basic transport of drugs in the tissue and all of these things, transport of blood from the blood vasculations and all. And after that, I'll be talking about reaction engineering, modeling batch and continuous reactor. Already these 3 and 5th topic I'll be covering together. And then I'll be dive to heat transfer in chemical process like coupling energy and mass balance. Then parameter estimation and sensitivity analysis in COMSOL. That is also very important topic. Let's see if we have experimental data and how we can calculate the parameter for this experimental data. Let's say if you have formulated the ordinary differential equation or partial differential equation, and from there let's say you have experimental data, and how can you put the experimental data in the COMSOL to calculate the parameter. Then we'll go for the coupling chemical kinetics with the transport phenomenon. That is also very important thing for the chemical engineer. And then we'll see the case study like drug delivery modeling in biological tissue, right? So and another case study will study in subsequent lecture, right? So first here I'll be talking about the need of COMSOL multiphysics in for chemical engineering, right? So let's say if we talk about multiphysics integration, so the COMSOL chemical process rarely involve just one physical phenomena. So a lot of physical phenomena are associated with the chemical process. So let's say example, if I'm talking about a catalytic reactor involves fluid flow, mass transfer, heat transfer and a reaction kinetics. So here in COMSOL that allow you to model all of these simultaneously in a coupled self-consistently, right? So then you can see that modeling real world reactors. So here in chemical engineering, often generally we focus on designing of batch reactors, CSTR, PFR and packed bed reactor. So COMSOL can simulate the internal physics of these systems, helping you to predict let's say temperature distribution in plug flow reactor along the length or the concentration profile. Obviously we calculate these things, and reaction rates as well as the pressure drop inside the reactor. Third, you can see that fluid flow and CFD for process design, right? So when we talk about understanding the laminar and turbulent flow in pipe, mixer and some other separator, which is very critical and we cannot visualize while solving the numericals only. So here in COMSOL, CFD model helps you to simulate flow behavior in complex geometry as well. So you can analyze pressure loss, mixing efficiency and velocity profile also. And after that, the fourth point is heat and mass transient analysis. That is very important. So whether it is designed, let's say if you are going to design a heat exchanger or distillation column, something like that, then COMSOL can model thermal conductivity or convection or evaporation and condensation also. It helps in optimizing the energy efficiency and separation process. That that you cannot do while solving the numericals only, right? And after that, fifth point is reaction kinetics and catalysis. All of these topics are very much connected to the chemical engineers. That's why I have taken all of these topics, and that will motivate you to understand why there is need of COMSOL multiphysics in chemical engineering. So here you can see that in reaction kinetics and catalysis, here you can see simulate homogeneous and heterogeneous reaction system. Also you can incorporate the RNS based kinetics, or you manually you can also some input the user define some kind of rate law. And also it models the reactor inside porous catalyst and membrane. That is very important. Sixth point is process optimization and scale up. So it helps in bridging the gap between the lab scale up and lab scale and industrial scale up process. So use COMSOL to test different configuration before building physical prototypes, right? That is very important. So if you are able to simulate all of these various kind of process in the COMSOL, then you can scale up it for the industry also, and you can also save the time, cost, and improve safety. And another point, that is seventh point, is very important for the educational and research tools. So this COMSOL is very excellent for teaching core concept of transport phenomena and reactor design, and it's widely used in research to model emerging technology, something like that, fuel cells, CO2 capture, battery modeling, drug delivery. All these are very hot topic in coming research these days. And after that, let's say if you know the COMSOL, so you can with the help of COMSOL app builder, you can create customized simulation tools for colleague short lines, something like that. So let's say if you're working as a freelancer for some industry also, and if any industry contacts you to model something, so you can develop some kind of app for the industry. So these are some kind of a very important fundamental concept that you can solve in COMSOL multiphysics. That's why this becomes very important. Okay. So with that motivation, we'll start with the lecture number 1 today for the introduction to the COMSOL multiphysics. Here in this lecture, we're only talking about the interface modules and workflow, how the COMSOL works. So let's start with these things here. So better here I'll stop this lecture first only, and in the next lecture, only in lecture number 2, I'll start with this because there is some issue in the network connection, so I won't be able to record this lecture today. So in the next lecture, I'll start with this interface model for the workflow in the COMSOL. Okay, thank you. See you in the next lecture.